its coordinates are p, x, y, z. And suppose we want to transform this vector from p, x, y, z to, let's say, spherical coordinate. So the vectors are r, theta, and phi. Okay. So suppose there's this vector, its length is r, and the angle that it makes from x-axis is phi, and the angle that it makes from z-axis is theta. Okay. So of course, any vector p, right, I can write as, let's say, xi plus yj plus zk. Okay. Or let me see. Yes. So I have a vector p, or let's say vector a. I can write as axx plus ayy plus azz. Okay. So this is how I represent a vector in Cartesian coordinate. The thing is, I want to represent the same vector in spherical polar coordinate. So how do I do that? Well, then I said, well, of course, AR is AR, R cap, plus A theta, theta cap, plus R theta phi, right? So A phi, phi cap. This is how we represent the vector. Okay. But then the thing is, we have to find out what is AR, A theta, and A phi. Okay. So there is a transformation for AR, A theta, A phi. And what is the transformation? The transformation is AR, A theta, A phi. That will be equal to a matrix. Okay. And then AX, AY, AZ. Okay. And this matrix is sin theta cos phi, sin theta sin phi, cos theta, cos theta cos phi, cos theta sin phi, minus sin theta, minus sin phi, cos phi, and 0. Okay. So this is how I can determine what is AR, A theta, and A phi, and I can put over here. Then I will have the same vector in the spherical polar coordinate. So this is what we have done. Transformation of a vector, or transformation of a vector field, okay, into, let's say, from Cartesian coordinate to spherical polar coordinate. So this is what we have learned till now. Can all of you hear me?
Yes, sir, you are audible.
Okay, okay. And you're following me now, what I'm saying?
Yes, sir.
Okay. So now what we are going to do is, we are going to look at the cylindrical coordinate. Okay. So before that, let me see. Yeah, so this is the problem, only 45 students. And okay, let me see. Okay, fine. So today we are going to look into the cylindrical coordinates. And so what is cylindrical coordinate? So suppose I have the same x-axis, y-axis, z-axis, and suppose there is a point P that we want to represent. So what we can do is, so this point P, we can identify this point by, let's say, rho, phi, and z. Okay. So now what is rho, what is phi, what is z? Rho. Okay. So let me just make a little bit change here. Let's say the particle is here. So this is point P. Okay. And this point P can be identified by rho, phi, and z. Okay. So rho is the radius. So this radius that you see, this is rho. Okay. Now let me say this was the vector r. So let me just do the same thing here. Just use a different color now. And so I have to draw a cylinder here. Not good. Okay, so this was vector r. So its tip was point p, rho phi z. So I can identify this point by rho, which is the radius of the cylinder. Phi is the angle that it makes from the x-axis. So this is phi, and z is the height. Okay, so this is cylindrical coordinate. Now the thing is we have to again look for the transformation equation. So let me just write it down here. Here the coordinates are rho, pi, and z, and these are our u1, u2, u3. Now let us look at the transformation equation. So what is x here? X is rho cos phi. Okay, because this length is rho. Okay, so its projection in the x direction is rho cos phi. What is y here? Y is rho sin phi, and z is of course z. Okay. Now, as we have done earlier, any vector r, which was earlier xi plus yj plus zk, now it can be written as rho cos phi I plus rho sin phi j plus zk. Okay. Now I have to find out the unit vector in the rho phi and z direction. So let us use the trick. So delta r vector over delta rho, that is cos phi I plus sin phi j. Okay. Now let me ask you delta r over delta rho.
Hi guys, so this video shows how
Magnitude, that will be square root cos square phi plus sin square phi, and that will be equal to 1. We have called earlier it as h1. Now therefore our rho cap will be cos phi I plus sin phi j, and let us underline this. Okay, now similarly let us find out what is phi cap. So what I have to do for that, we will calculate delta r vector over delta phi. Okay, so this is our master equation. From here we will find out what is delta r over delta phi, and you can easily see that is a rho sin phi I cap plus a rho cos phi z cap. Okay, and of course I can take a rho common, that is minus sin phi I plus cos phi j. Now what is delta r cap? Delta r over delta phi, that is a rho, and we call this h2. Okay, h1 h2 are the scale factor. So therefore our phi cap will be minus sin theta I plus, okay, this is phi. Okay, sin phi I plus cos phi j. Now let us look for the unit vector in the z direction. This we already know, by the way. delta r over delta z. This is obvious. It is k cap, and just for the sake of completeness, let us write it down that that will be 1. And this is my H3. Fine. Therefore, Z cap will be K cap. This is what that we want. Now let us write down the formula for differential length, differential surface area, and differential volume in cylindrical coordinate. So dl, which is the differential length, that will be h1 du1 u1 cap plus h2 du2 u2 cap plus h3 du3 u3 cap. Okay. So that will be d rho rho cap plus rho d phi phi cap plus dz z cap. Okay. All of you are following me, na? Yes, no?
Yes, sir.
Yeah. Okay. Yeah. Okay. So now let us look at ds. ds will be h1 du1 h2 du2. Okay, so this is the magnitude, and of course if you want to write down, then it will be in the direction u3 cap. Okay, so that will be how much? 1 r1 1 row 1. So 1 row d row d5, and in the direction z cap. Okay, so I'm not writing it, but if you want, you can just write down that it is in the k direction. Now what is dv? dv is h1 h2 h3 du1 du2 du3. So that is 1 row 1 0 d5 dz. Okay, now the last thing is the distance between 2 points. So suppose we have 2 points 1 and 2, and its coordinates are x1 y1 z1 x2 y2 z2. So and then earlier we wrote that d square is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So here we will have, because we have the transformation equation now, we know the value of x, y, z. Okay, from here, so these are our transformation equation. You can just plug there. So you will get d square equal to row 2 square plus row 1 square minus 2 row 1 row 2 cos phi 2 minus phi 1 plus z2 minus z1 square. Okay, so this you can check. It's very easy, huh? Very simple algebra. So if you have any question about this, you can ask. Okay, now let us look the matrix form, because this is very important, huh? So this will be useful when we transform from one coordinate to other. So in the matrix form, so for the unit vector, because we have the equation now, I'm talking about these equations. So let's say this equation, and this equation. Okay, let me just write it down. P. So this is our first equation. Second equation, third equation. By the way, this z cap and k cap, they are same. So in one case I use k cap, in other case I am using z cap. So they are same. Okay. So by now you know that. So now what do we want? We want, let's say, to write the matrix, this transformation in the matrix form. So it is very easy. I mean, let's say going from I j k to rho phi z. Okay. So let me just write down rho cap, phi cap, z cap equal to a matrix into I cap, j cap, k cap. Okay. So now let us look at these equations. So rho cap is cos phi I. So there has to be a cos phi here, cos phi I, and cos phi sin phi j. So it has to be a sin phi j and 0. Okay. So similarly, you can just write it down 0, 0, 0, 1. Okay. So up to here, everything is clear.
Yes, sir.
That is, yeah, that is why we need this equation, because for this transformation. Now if you want to transform from, let's say, rho phi z to izk, then it is just inverse of that. But for the completeness, let us write it down izk. So how do we make this transformation? It is just inverse of that. Okay. So I j k, and since its determinant is 1, so it will be just transpose of that. Okay. So it will be cos phi sin phi 0 minus sin phi cos phi 0 0 0 1. Okay. Into rho cap, phi cap, z cap. Okay. Or alternatively, you can just write it down as I j k is equal to a matrix, a rho cap, phi cap, z cap, and I dot rho. So this is dot product I dot phi cap, I dot z cap, I dot, sorry, this is z now because we are in the second row. So this is j dot rho cap, j dot phi cap, j dot z cap, h dot rho cap, sorry, this is not h, it is k. Okay. K dot rho cap, k dot phi cap, and k dot z cap. And then I said even the component of the vector transform the same way. Okay. So let me just rewrite that. So I have this. So the same thing will be here. Now we are talking about component, not the unit vector. Huh? So you have to be, so arrow a phi az, and it will transform the same way ax ay az. What is ax y ax ay az? Anyone?
सर वेक्टर जो लिखा था ना हमने a equals to ax I cap,
हाँ, exactly. So these are the component of the vector along the I, j and k direction. I, j, k are the unit vectors. Whatever derivation that we have done till now, we find out the unit vector in rho direction, phi direction, z direction. Okay, and then from those equations we wrote a matrix. Okay, those matrix we wrote in the form of unit vector. Okay, so how the unit vector transform, and then I said even the component transform the same way. Okay, and this is universal. Huh? Same thing we have done for Cartesian coordinate, spherical coordinate and now for cylindrical coordinate. Okay, so yeah, so let us just write it down. The same thing I'm going to write down: cos phi, sin phi, 0, minus sin phi, cos phi, 0, 0, 0, 1. Okay, and let us just write it down once again. If you want to determine what is ax, ay, az, and suppose the cylindrical components are given. So in this case, now you are given a rho, a phi, az. Okay, then that matrix will be just the transpose of this. So it will be cos phi minus sin phi, 0, sin phi, cos phi, 0, 0, 0, 1. Okay, so this is all about the coordinate transformation. Now let us do one thing. Let us look for an example maybe. Okay, so that you will get the idea actually what is going on. Okay, so let me just solve one example. By the way, in this course I'm not going to solve many problems like the one that we have done in mechanics class. The reason is you have one tutorial per week. Okay, so I mean every week you have one tutorial class, and in the tutorial class you will solve like 7 8 problems. Okay, so that is why we will emphasize more on the concept, more on the topic, but we will not solve many problems. Okay, but sometimes it is important to really understand like what is going on. So I will solve some of the examples, some of the questions, but not all of them. So let us look at one question. So let me just write it down, the problem statement, very simple. So let's say not question. These are examples. So example number 1. Suppose there's a vector. So let me just write down in the question form. Express the vector. Okay. So there's a vector. Let's say vector A. By the way, this can be field also. So you can assume it as if this is electric field or magnetic field, whatever you want. So, but we have not reached there. So let us call it a vector. Suppose there is a vector A and it's given as vector A equal to y ax plus x plus z ay. And the question is to express this vector in spherical and cylindrical coordinates. Okay, so this is the question, that a vector field is given or a vector is given. It's this, and you have to find out, or you have to express this vector in the spherical and cylindrical coordinates. So let us first. So how do we approach the problem? Can someone suggest? How do we start this problem? Yes, because this is what like I mean you have to do, in many of the problems. You have field, you have vector in one coordinate system, and sometimes you want to transform that in spherical or cylindrical coordinate. So how do we start this problem?
Sir, I want to ask one thing, that AX bar and AY bar are unit vectors.
These are yeah, so actually it is not mentioned in the question. Okay, but yes, ax bar and ay bar, these are the unit vector along the x and y direction. Okay, so in the problem statement it is not given, but this is something that yeah, so these are the unit vector in the x direction and y direction. Okay. So one thing that we can do immediately is, so what do we want? We want to express this vector A, okay, in the spherical coordinate. So in the spherical coordinate, how the vector will look like? It will look like some component AR r cap plus a theta theta cap plus a phi phi cap, right? And in the select coordinate, this will look like arrow, rho cap plus a phi pi cap plus az z cap, right? This is how the vector will look like. And what we have to do, we have to find out ar, a theta and a phi, for example, in this case. And in this case we have to find out a rho, a phi and az. Okay, let us first look at the spherical coordinate. So let me just write down. So first we are doing for the spherical coordinate. So what are the transformation equation? Note that ijk or ax, ay, az are given here. Okay, so with this I know what is ax, ay, az. What I have to find out? I have to find out ar, a theta and a phi. So ar, a theta, a phi. I have to find out this. Once I find out this, I will put in equation number 1 and the problem is solved. Okay, so there is a matrix here, and what is given in this question? Ax, ay, az. Okay, this is given here. So what is the matrix? So you can look at your notes. Sine theta
Cos phi.
cos phi, yes, correct. Sine theta, and by the way, this is a closed book exam, so you have to remember some of the things. Okay, sine phi cos theta, okay, cos theta cos phi, cos theta sine phi, minus sine theta minus sine phi cos phi and 0. Okay, now let us look here. What is ax? Ax, how much is ax? Anyone? Y, correct. So this is the, yeah, this is the component of the vector in the x direction. Okay, so this is my unit vector. Along that direction, ax is y. This will be how much? X plus z, and this will be equal to 0. Okay, now the life is set, so we can just find it out. So therefore ar is y sine theta cos phi plus x plus z sine theta sine phi. A theta will be y cos theta cos phi plus x plus z cos theta sine phi, and a phi will be minus y sine phi plus x plus z cos phi. Okay, now is this the answer? If I plug this in equation number 1, is that the answer?
No, sir. We have to convert x, y, z into their respective spherical.
Yes, yes, very good. Yes, so we have to get rid of x and z, because look, x, y, z, these are not the part of the spherical coordinate. So we have to get rid of x, y, z. So for that, what do? We have the transformation equation. So let us use, so let me just, anyway, let me just write down. We have to get rid of x, y, z, and for this we can use the transformation equation. What is the transformation equation? Well, x equal to r sine theta cos phi, y equal to r sine theta sine phi, and z equal to r cos theta. So you can put this, well, let me just call it equation number 2. Okay, so put it in 2, and you can use 1. Okay, because we have to put it here, and then we have to just put in this form, you know. So let me just write it down. Vector A in the spherical polar coordinate. So earlier we had this vector. Now in the spherical polar coordinate, this vector or vector field, it will be r sine square theta, r sine square theta, sine phi, cos phi plus sine theta, cos phi plus cos theta into sine theta, sine phi. Let me just write it down, r cap plus r sine theta, sine phi, cos theta, cos phi plus sine theta, cos phi plus cos theta into cos theta, sine phi, theta cap plus r minus sine theta, sine square phi plus sine theta cos phi plus cos theta into cos phi r theta phi cap. Okay, so this is how we represent the same vector from, I mean, this is how we can transform a vector from Cartesian coordinate to, let's say, spherical coordinate. Now let us look at the transformation to the cylindrical coordinate. Okay, so let me just write it down. So here I wrote spherical coordinate, so this is cylindrical coordinate. So again, it is very simple because we have the machinery now, a rho, a phi, a z. These are the component along the rho, phi and z direction. There is a matrix, transformation matrix, and then ax, ay, az, and this is y, this is x plus z, and this is 0. So what is the transformation matrix? Cos phi, sin phi 0, minus sin phi, cos phi 0, 0, 0, 1. Okay. So let us find it out. The component. So components are a rho, that will be y cos phi plus x plus z sin phi, a phi minus y sin phi plus x plus z cos phi, and az is equal to 0. Okay, again remember that z is okay because z is there in the cylindrical coordinate, but x and y should not be here. So again we have to use the transformation equation. So we have to get rid of x and y using transformation equation. And what is transformation equation in cylindrical coordinate? Well, x equal to rho cos phi, y equal to rho sin phi, and of course z is equal to z. Okay, so again do the same thing, put in 3 and use equation number 1. Okay, so vector a, let me just write it on the final answer, that will be rho cos phi sin phi plus rho cos phi plus z sin phi, unit vector in the rho direction, plus minus rho sin square phi plus rho cos phi plus z cos phi in the phi cap direction. Okay, and okay, let's say plus 0 in the z cap direction. Okay, so this is the answer. So this is how we can transform, in principle, any field, any vector field, from Cartesian coordinate to spherical polar coordinate to cylindrical coordinate, from cylindrical coordinate to spherical coordinate, from cylindrical coordinate to Cartesian coordinate, and so on. Okay, so just using these matrices, we can go from one coordinate system to other coordinate system. Okay? If you have any question, any doubt, you are free to ask.
Sir, we can also convert a cylindrical into spherical by.
Yes, 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 yeah, yeah, yeah. So yeah, so okay, so let me just write it down. So what he has asked is he want to convert, let's say, just check, so he want to, let's say, transform, okay, transformation from, let's say, spherical to cylindrical, right? I mean, of course, vice versa you can do just by taking the inverse. Okay, so let's say from spherical to cylindrical coordinate. Oops. Okay, so one thing we can do immediately is, okay, from spherical we can go to Cartesian, and from Cartesian we can go to cylindrical. Okay, but of course they are direct matrices, very simple matrices. Okay, with that also you can transform. Let me see if I have here. Yeah, so okay, so let me just write it down in the final form. So this is one way that you can go through, or you can follow the same algebra that I have followed, but let me just write it down, the final answer. Okay, so let's say, mm, AR, A theta, A phi. Okay, so again these are the component along the r theta and phi direction. Okay, there will be a matrix and the cylindrical coordinate, which is a rho, a phi, and az. Okay, so what is the matrix? The matrix is sine theta 0, cos theta, cos theta 0, minus sine theta 0, 1, 0. Okay, so this is this is the matrix by which you can transform from spherical to cylindrical or cylindrical to spherical. Okay, so now these are like very important result, because like as someone of you ask, like, why we are doing this, coordinate transformation, but you will see that in many of the cases, sometimes, solving a problem is easy in spherical coordinate, in other case it is easy to solve in cylindrical coordinate, in some case it is easy to solve in Cartesian coordinate, depending upon the symmetry of the problem. Okay, so there you will find it very useful. That is why, these results were important and we require them. Anything else about this? So okay, so let me just extend this little bit more. So this is the extension of the same problem. In the same problem, let's say you are given point P, okay, and its coordinate are -2, 6, and 3. Okay, and it asks you to evaluate P in spherical and cylindrical systems, coordinate systems. Okay, so you got the point. What is happening here? Suppose there's a point that, let's say, its coordinate is -2, 6, and 3. I do not say that -2 is on that side, because I am not taking care of that. where it should lie. The thing is, there is a point P and its coordinate is -2, 6 and 3. And so this is x-axis, this is y-axis, this is z-axis, and it is asking you to write down this coordinate in r theta phi form and in rho phi z form. Okay, so this is what it is asking you to calculate. So let us see, we have to find out r. So let us first calculate for spherical coordinate system. Okay, so for spherical coordinate, what is r? R is, so if you are given x y z, okay, then if you have to find r, it is simple, x square plus y square plus z square. Okay, what is theta? Theta is tan inverse square root x square plus y square over z. What is phi? Tan inverse y over x. Okay, okay, like, I mean, is this fine, or you want me to draw the axis again? So this is x-axis, this is z-axis, this is y-axis. Suppose there's a point, oops, suppose there's a point P, this point is P, okay? And now this is R, its coordinate is x, y, z. Then of course R will be square root x square plus y square plus z square. Now what was theta? Theta was this angle, right? So this is our theta. So its projection is over here. So what will be tan theta? Tan theta will be this distance. Okay, tan theta will be this distance divided by this distance. Okay, and how much is this distance? This is equal to this, and this is nothing but x square plus y square square root. Okay, and this is z. So therefore tan theta will be square root x square plus y square over z. Is this fine?
Yes, yes, sir.
Right. This is very simple trigonometry, huh? No physics. Very simple 12th class trigonometry. Okay. So I have r theta phi. I know what is x, y, z. So x is -2, y is 6, and z is 3. Okay. I can just put here and find out what is r theta phi. Similarly, for cylindrical coordinate, rho. Okay, rho will be square root x square plus y square. You can just see from here, huh? This is where is the coordinate system. Okay, so this is our rho, the radius. Okay, this is x square plus y square. Okay, so that is our rho. Phi is tan inverse y over x, and of course z is equal to z. And if you put all these values, you will see that p, which was -2, 6 and 3, that will be p. So in spherical coordinate, it will be 7, 64.62 degree, 108.43 degree. Okay, so I have just put the value here. Okay. This value of xyz over here, value of xyz over here, and value of y and x over here. And in the cylindrical coordinate, it will be point P, 6.32, 108.43 degree, and 3. Okay, so this is the answer. Fine. Now I am going to give you one problem for the homework. You don't need to show me that you have done or not, but this is your homework problem. So let me just write down the problem statement. Okay, this is question. So express the following vectors in Cartesian coordinate. Okay, so the first vector is, let's say you have a vector A. It is a row z sine phi a row cap plus 3 a row cos phi phi cap plus a row cos phi sine phi z cap. And let's say second vector is vector B. It's r square r cap plus sine phi phi cap. Okay, so you have to transform this vector into Cartesian coordinate. Okay, so all of you know now, I mean, how do we do that? So what you have to do is, you have this rho phi z. Okay, there will be a matrix, and then there will be x y z, x cap y cap z cap. Sorry, I have to do the inverse of that. Okay, because this time rho phi and z are given. Okay, so I will have x cap y cap z cap equal to this, and rho phi z. Okay, so you fill the matrix here, find out. Okay, this is not x cap, by the way. This is ax ay az. You are following now, all of us? Ax ay az.
Yes, sir.
Okay, these are the component, huh? I'm just giving you the hint. Okay, so the final vector A will be ax x cap plus ay y cap plus az z cap. And now ax ay az, you know. Okay, because you know the matrix, and this will be whatever a row that is given here. This is our a row, this is our a phi, and this is our az. Okay, so please do this. This is a homework problem. Let me just write down the final answer of this. So a will be 1 over a square root x square plus y square xyz minus 3xy x cap plus zy square plus 3x square y cap plus xyz cap. Okay, now this is vector A. Vector B will be 1 over square root x square plus y square plus z square x x square plus y square plus z square minus y x cap plus y x square plus y square plus z square plus x y cap plus z into x square plus y square plus z square z cap. Okay, so this is the answer. Okay, so almost we have, I would say, we have covered everything that was required. Okay, so this is how, again, let me say that how we will transform the vector or the vector field, electric field, magnetic field from one coordinate to other coordinate. This is the same formalism that we are going to follow in this lecture. If any one of you has any doubt, you are free to ask. Or I think all of you understand
Sir,
this, because some of, yes.
we have to learn the derivation also or just the result?
Well, you are asking for the exam.
Yes, sir.
Well, about the exam, right now I cannot comment. Okay, this much I can tell you that it will be a closed book exam. Okay, and of course you should know the derivation, because this is not, MCQ type of question. At least in the final sem you will not have MCQ type of question. This is a proper course. Okay, so you should know the derivation, you should know the definition, you should know how do we solve a question. So everything is the part of syllabus. Okay, because sometimes, we can just ask the definition.
Okay, sir.
Okay, this is a subjective exam. Okay, so this is slightly different than what you have done in let's say mechanics or some other course, because there just question answer, but this is a proper physics course. So you should know the derivation. And by the way, I mean, even the derivation is not very difficult. Okay, we have started from first principle only. Okay, and then we slowly derive the formalism, final result. But all of them are not very difficult, very easy. And if you ask me whether you should know it or not, of course you should know it.
Okay, sir.
Okay, yeah. So right now I cannot comment what kind of exam will be there, but this much I can tell you, that this time it is going to be a closed book exam. This is what we have decided. About the exam we have not thought. Probably probably for the mid sem we might use Moodle. Okay, so for the mid sem. Okay, so maybe your mid sem will be some kind of question answer and so on, but the final sem will be a full fledged subjective exam. So we may ask definition, we may ask derivation. Okay, so all these things we can ask, and of course questions and concept. Fine. Anything else, because it's already 3:57? Or let me just discuss something else. I mean, if you have time, then let me just.
Sir, we have class.
You have class. Yeah, I can understand. Yes. Yeah. Okay. So, by the way, just see, because the participation is quite less. Okay. And let me tell you that this may affect your CWS marks. And though I'm not very strict, I would say. Okay, to cut your marks on the attendance, because that is not the policy that I follow. Okay, if you know, then you know. I mean, then in principle, there is no need to come to the class. Also, I am happy with that. There's no problem. But I will suggest, because this is a 4 credit course, very important course. Okay, and we want to make it rigorous. Okay, because there are a lot of things that we have to cover. This is the first course on magnetism, and of course this is very interesting course, very interesting topics. Some of them I understand. It's like mechanics, like part of the concept, but there are many gap area. So those things we have to fill. So I will request all of you, okay, to come to the class, participate in the discussion, be active on the discussion forum. I'm also available on the phone. Okay, I've shared my like now we have the WhatsApp group. So please be active, interact among yourself, interact with me, so that we can make this course even more fruitful. Okay, so if there are no more questions, then let me stop the meeting. Have a nice weekend. Let us meet on Monday then.
Thank you, sir.
Thank you, sir. Okay. Bye bye.
Thank you, sir.
Thank you,
Bye
sir.
bye.
Thank you, sir. Thank you, sir.
Bye.